A second Earth. Perhaps even a planet better than Earth, scientists have discovered, and in this video we look at fascinating original footage and travel light years to immerse ourselves in the exciting world of exoplanets. Be sure to stay tuned until the end so you don't miss anything, and if you like it, I'm galactically happy about a thumbs up and a comment, because that's how we get the YouTube algorithm to show this video to even more people. Thank you guys and welcome. Do you often feel the same way? You look up at the starry sky at night and suddenly feel this almost unbearable fascination at the thought that there are an infinite number of other solar systems out there, with planets, moons, dwarf planets, comets, and all the trimmings. We are literally less than a grain of sand on a cosmic beach, and there are worlds out there that we can't even imagine in our wildest dreams. I would describe the feeling I get from this thought as cosmic wanderlust. Let me know in the comments if you have it too. In any case, we know a few of these billions of exoplanets. Thanks to advanced space telescopes, we have already been able to unravel the secrets of some of these exotic worlds. And there are actually some that appear to be similar to Earth. Not only have we already discovered a potential second Earth, but NASA has even found planets that could be better than Earth. In the following video, we'll take a look at all these spectacular discoveries, as I've compiled the most incredible breakthroughs in exoplanet research for you. And I'd say let's get started right away. Let's travel to the second Earth together. In our galaxy alone, there are probably around 200 to 400 billion star systems with an average of 2 planets each, calculated pessimistically. That would bring us up to 800 billion planets in our Milky Way alone, plus moons and dwarf planets, which could in principle also be habitable. So with this sheer mass of planets, there's certainly a planet B and also a planet C and D, E, F,
2 hours later,
and Z in terms of living conditions. It is difficult to discover just these planets, because the galaxy is huge and planets are small. Even with the best space telescopes, we have only been able to observe our immediate galactic neighborhood really well. Most of the exoplanets that we have discovered so far, over 5,000 of them, are gas planets. These are gigantic alien worlds that resemble Jupiter, Saturn, Uranus, or Neptune in appearance. Super exciting, but planets without a solid surface are not very suitable for life. So what we are really looking for are smaller rocky planets. And the holy grail of exoplanet research is rocky planets in the habitable zone of your system. What is the habitable zone? You can imagine it like this. In your home, the habitable zone would be your couch, with a side table for pizza and the TV with Netflix in front of it. In other words, the area where life thrives best, especially if you let the pizza crumbs vegetate in the crack of the sofa for a few months. Of course, I'm not speaking from experience. In star systems, the habitat zone refers to the area where the temperature is just right for life-friendly conditions, according to our understanding. In other words, where water would neither freeze nor evaporate, but can remain in liquid form. Of course, it must always be said that alien life forms would possibly require completely different conditions. Perhaps a habitable planet for certain species would have to be a gigantic ice desert very far away from its star. But we are looking for planets that would be life-friendly for us. And their location must lie in what we define as the habitable zone. This zone is not at the same distance from the star in every system. In the case of red dwarf stars with low temperatures, the habitable zone would be very close, as can be seen here using the example of Proxima Centauri. With blue, super-hot stars, the habitable zone is correspondingly further away. And what NASA has now discovered in the TOI 700 system really is the jackpot in the search for exoplanets. TOI 700 is a red dwarf star that is only just over 100 light-years away from Earth. In cosmic terms, it is practically on our doorstep. NASA's Space Telescope TESS, short for Translite Exoplanet Survey Satellite, has been taking a close look at this system for several years, and now finally the big breakthrough. NASA has announced the following.
We learned a hard lesson during the pandemic. 1/3 of core inflation we faced last year is because of automobiles, the cost. Why? We had a lot of buyers because wages went up.
Oh crap, fake news. NASA has announced that it has discovered an Earth-sized planet in the habitable zone. The planet, named TOI 700e, is 95% the size of Earth, made of rock and at the right distance from its star for liquid water. If that's not a second Earth, I don't know what is. Here you can see a NASA animation of what this Earth might look like. Tests can examine the most important details of this planet, but original images of the surface are unfortunately not possible at this distance. I can already hear some of you saying this indignantly.
If there are no original recordings, I don't believe it. Fake news, NASA.
Such exoplanets are discovered indirectly by observing the star's light curve. When an exoplanet passes by its star, the star is minimally dimmed and the light curve drops. This is called the transit method, and here you can see the light curve of TOI 700, which was used to discover the new exo-Earth. But this discovery was really tricky. Planetary researcher Emily Gilbert from NASA's Jet Propulsion Lab describes it like this. If the star had been just a little closer or the planet a little bigger, we would probably have found TOI 700e in the first year of tests. But the signal was so weak that we needed another year of transit observations. Before you pack your bags and head off to Pandora as the Avatar, there are of course a few uncertainties. First of all, just because a planet is in the habitat zone doesn't mean that water exists there. After all, it is still not completely clear how the water came to Earth. Presumably some of it came from comets that hit the Earth and some from water that was already bound in the Earth's rock. But whether this also happens on other planets is completely unclear. TOI 700e probably has a bound rotation around its star, which means that one side is permanently facing the star and the other side is permanently facing away. On one side is eternal hot day and on the other eternal night and freezing cold. Does this rule out life? No, because researchers have just discovered that life could thrive wonderfully in the intermediate area between day and night, the so-called terminator zone. So I think that the chances of extraterrestrial life on TOI 700e are not bad at all. And what's more, we even have another candidate in the same system, TOI 700d. Astronomers are really uncreative when it comes to naming. It was discovered in 2020 and is also located in the habitable zone, is also about the same size as Earth, but also has a bound rotation. So we have two potentially habitable planets in one star system. Awesome, right? Emily Gilbert says, this is one of the few systems with several small habitable planets that we know of. This makes TOI 700 an exciting target for further investigation. You really have to assume that life and habitable planets are teeming out there, don't you? Let me know what you think in the comments. Is Earth something special, or are habitable planets with liquid water super common in the Milky Way? I'm very curious to hear what you think, and we'll try to answer as many comments as possible. The problem with many of these exoplanets is that they are very far away, and unless we invent the warp drive, it will be difficult to get there for the time being. That's why the following discovery is so spectacular. A very special planet has been discovered right next to us, in our neighboring star system Alpha Centauri, Proxima b. It is very fortunate how much our cosmic environment seems to have been made for us humans. First of all, the Earth has a satellite, the Moon, on which we could practice space travel. Then our neighboring planet Mars is Earth-like and perhaps suitable for colonization and accessible to us, and our nearest neighboring star system Alpha Centauri probably contains several exoplanets on which life could exist. So it couldn't be any better. Imagine if Earth was the only planet in a star system where there was nothing else. Then we wouldn't have any objects to move to. But everything actually looks pretty good for us. This neighboring star system Alpha Centauri consists of 3 stars, Alpha Centauri A and B and Proxima Centauri. Proxima Centauri has long been considered the most interesting of these 3 stars because, as the name suggests, Proxima is Latin for the nearest or closest. It is closest to our star system. And because an Earth-like planet called Proxima b had been discovered around Proxima Centauri. But many people are skeptical about whether Proxima b could really harbor life or whether it is suitable for colonization, because unfortunately Proxima Centauri is a very active star. This means that there are massive solar storms or stellar storms and massive ejections of matter. On March 24, 2017, for example, an apocalyptic event was recorded in the Proxima Centauri system. There was a burst of radiation that caused the brightness of Proxima Centauri to increase 1,000-fold for a few seconds. This burst of radiation probably hit the planet Proxima b with full force. Such an event would lead to a global catastrophe on Earth. For example, such massive bursts of radiation are not known from the Sun, which is strange, because the Sun is larger and more active than Proxima Centauri, which is only a red dwarf star. but a very, very active one. That's why astronomers decided a few years ago that the search for habitable exoplanets should perhaps be redirected away from Proxima Centauri and towards Alpha Centauri and Alpha Centauri b. And the Very Large Telescope of the European Southern Observatory in Chile has been equipped with new instruments specifically for this purpose, for example with a so-called infrared coronagraph. This captures infrared radiation in the wave range around 10 micrometers, but shields the telescope's optics from the direct radiation of the star. The effect is that the weaker thermal radiation of a potential planet around the star then becomes visible. This so-called NIR instrument was used to observe Alpha Centauri A for a total of 19 nights in May and June 2019, and the results are now available. Here you can see one of the infrared images, and the analysis has now shown that a spot of light that can be seen in this image is very likely a habitable planet. It has been given the provisional name C1. A brief digression on the subject of binary star systems and the probability of life in such multiple star systems. It used to be assumed that binary star systems, i.e. a system with more than one sun at its center, were the exception or did not exist at all. Today we know that binary star systems are probably the rule rather than the exception. Conservative estimates assume that 50% of all star systems in the Milky Way are binary star systems. Some researchers even say that over 70% of all systems have more than one star at their center. Most of them have two stars, i.e. binary systems, and some, like Alpha Centauri, even have three stars that are somehow gravitationally bound to each other. If this is true, then our solar system with the sun as one star in the middle would indeed be the exception. And that begs the question, what is better for the emergence of life? A single star system or a multiple star system? We know from ourselves that life is possible in a single star system. That makes sense, doesn't it? It makes sense because the planets can rotate in a fixed orbit around a single star like the Sun, and there are no other gravitational influences that would interfere. In a binary star system it could be different, due to the gravity of the other star. We can distinguish between two different types of planets in a binary star system, namely between types P and S. The P-type planets rotate around both stars, because in a binary star system like Alpha Centauri, the two stars rotate around each other and they have a common gravitational center. This is called the barycenter, and a P-type planet orbits the barycenter of the two stars. This is actually similar to our solar system. It doesn't really orbit a star center, but the barycenter of two stars. This creates a certain constancy, even if the two stars, especially if they are different, can of course have different effects on the planet. Whether this is beneficial or detrimental to the development of life depends very much on the characteristics of the respective stars. And then there are the S-type planets, which are so close to one of the two stars that they don't orbit around the barycenter, but around just one of the stars. This is the case with C1 in our case, which does not revolve around the barycenter of Alpha Centauri A and Alpha Centauri B, but only around Alpha Centauri A. This in turn could also be favorable for the formation of life, depending on what the star around which the planet revolves looks like. But of course there can still be blatant effects if one star changes its position in relation to the other stars. So it's hard to say whether this is really favorable for the emergence of life. Kevin Wagner, an astronomer from the University of Arizona who was involved in this research, says the following. In a relatively small area of the images, there is a point-like heat source that does not match any of the known detector artifacts. This point of light can be seen in many independently acquired images, which makes it unlikely that this is a false positive signal. In other words, this is very probably a planet. This is also supported by the fact that if you superimpose the 19 images from the 19 nights of observation, you can see that C1 is moving slowly. This again suggests a planet that has a fixed orbit around its star. And it gets even better, because C1 is 1.1 astronomical units away from Alpha Centauri A, so it is on the inner edge of the system's habitable zone, i.e. the area in which a planet could be life-friendly, because it has the right temperature and the right distance to the star. This means that C1 is basically a candidate for life. If there's a planet with life in the Alpha Centauri system, then it should be exactly where C1 is. Based on the luminosity of C1, it is also possible to say approximately how big this planet should be, and the research team believes that it is around 3 to 7 times bigger than the Earth, so it would be around the size of the planet Neptune. However, this does not necessarily mean that it is a gaseous planet. There are already several known exoplanets in alien star systems that are much larger than Earth, but are still so-called terrestrial planets, i.e. made of rock and soil. We then speak of a super-Earth or a super-exo-Earth, depending on how spectacular we want it to sound. In other words, we might have a super-Earth here with C1 in the habitable zone with life. That would probably mean that this planet is also heavier than Earth, which means we would have a much stronger gravity there. If there is life there, then the life forms would of course have adapted to this more massive gravity and would probably be smaller and stockier. But that is of course just speculation. For us humans, a planet that is so much larger and probably heavier than Earth would probably not be so suitable for life. A completely new chapter in exoplanet research has been opened with the James Webb Telescope. This best space telescope that mankind has ever built allows us to look deeper and in more detail into the cosmos than ever before. And James Webb has already discovered an exoplanet that has really taken researchers' breath away. James Webb has confirmed his first exoplanet, i.e. a planet outside the solar system that revolves around another star many light years away. But I can already hear some of you objecting angrily.
A few weeks ago you told us about James Webb and an exoplanet. Liar Tim.
That's true, but a few weeks ago it was all about James Webb having set his sights on an already known exoplanet. Now, for the first time, James Webb has discovered a completely new exoplanet. And on the one hand, this is great news, because one of James Webb's main purposes is of course to analyze alien planets more closely and look for signs of extraterrestrial life in their atmospheres. On the other hand, it's fantastic news because this newly discovered exoplanet really has it all. This artist's impression shows us what the planet might look like. It lies in the constellation of Octon and, as always, has an easy-to-remember name, namely LHS 475b. I'm going to call it the James Webb Planet because I don't feel like pronouncing this cumbersome name 10,000 times. So the James Webb Planet is only 41 light-years away from Earth and orbits a red dwarf star. Our galaxy is a total of 100,000 to 200,000 light-years across, so 41 light-years is really right on our doorstep. The researchers involved, Kevin Stevenson and Jacob Yeager, say, "There is no question that the planet is there. The impeccable data from Webb confirms this. The fact that it is a small rocky planet is impressive. Why is the planet so special? Here comes the real sensation. It is 99% the size of Earth. So, here we have a planet that is almost exactly the size of Earth and only a cosmic stone's throw away from us. Potentially a second Earth in our galactic neighborhood, discovered by the best space telescope of all time. I wonder why such great news never makes it into the big news programs. Instead, the average person lives with the following level of knowledge.
I'm very highly educated. I know words, I have the best words, but there's no better word than stupid.
But is it really a second Earth? Or is the planet just similar in size? James Webb can obtain information about the atmosphere using his high-resolution infrared eyes. Here you can see various models of the exoplanet's atmosphere based on the so-called transmission spectrum. The researcher involved, Aaron May, says, "The telescope is so sensitive that it can easily detect a range of molecules, but we can't draw any definitive conclusions about the planet's atmosphere. There is still no definitive certainty about the atmosphere of the James Webb planet, but there is one very exciting indication. Researchers suspect that the atmosphere is not similar to that of Earth, but of another celestial body in the solar system. Before I tell you which one it is, let's do a little knowledge test for you. Which celestial body in the solar system is most similar to Earth, i.e. who comes just behind Earth in the solar system in the Earth Similarity Index? Stop the video now and write your best ideas in the comments. Done? Then here's the solution: Saturn's moon Titan. With its dense atmosphere and lakes on the surface, it comes closest to Earth. Which doesn't mean that there aren't huge differences. The lakes on Titan's surface consist of liquid methane, and its atmosphere would literally take your breath away thanks to its high nitrogen and methane content. So it's best to book your next all-inclusive vacation in Hawaii rather than on Titan. And the trend among scientists is that the James Webb planet could have a very similar structure to Titan. Although this makes terrestrial life and an onslaught of fat all-inclusive tourists unlikely, life itself could probably thrive on such a planet. After all, Titan is also considered one of the most likely places for extraterrestrial life in our solar system. This life would have to be perfectly adapted to nitrogen and methane deposits. You can only let your imagination run wild as to what such aliens might look like. The James Webb planet has another tiny little problem. It is very hot. Although it orbits a red dwarf star, which is only half as hot as the Sun, the planet is very close to it. It only needs 2 Earth days for a complete revolution around its star. That's pretty fast. Imagine a year on Earth would only take 2 days. Birthday again. And another cake. All in all, you could say that this planet is a mixture of Titan and Venus. From my point of view, a super fascinating idea, like straight out of a science fiction novel, Attack of the Venusian Titan Aliens or something. And this is the beginning, because James Webb has now proven that it is possible to discover small Earth-like exoplanets. This is the holy grail of exoplanet research, so to speak. Finding giant exogas planets is much easier and also possible with many other telescopes, because these planets are incredibly large. But discovering small rocky planets has always been difficult. James Webb has now shown that it can be done, and we can now look forward to many more discoveries of planets that could potentially harbor life. As exciting as exogas planets are, extraterrestrial life is unlikely to be found there, so we have to look for it on smaller planets with solid surfaces. This is how Stevenson and Yeager see it. And it's just the first of many discoveries Webb will make. With this telescope, rocky exoplanets are the new frontier. Okay, these exoplanets are all well and good, but what if there are not only planets that are similar to Earth, but that are even better than our Earth? I'm talking about so-called superhabitable planets. And if you're wondering how a planet can be better than Earth, then pay attention now. Let's travel directly into space and take a look at our solar system. This green area here is the habitable zone, the area in which life appears conceivable by earthly standards. But what does that actually mean? Life seems conceivable. And how do scientists determine where the habitable zone begins and ends? It is possible to visualize such a habitable zone not only here, but also in other star systems. Here, for example, in the TRAPPIST-1 system, in which there are 7 terrestrial planets and 3 to 4 of them are in the habitable zone, depending on the interpretation. In the search for habitable worlds, scientists usually focus precisely on this habitable zone, as this area defines the distance between a planet and its star in which the temperatures are moderate enough to allow liquid water on the surface. As water is considered a prerequisite for life on Earth, the identification of Earth-like planets in the habitable zone is a promising approach. But I don't know about you, but somehow the term habitable zone is a bit geocentric when it's only about earthly living conditions, isn't it?
This classification comes from a racist system, you alien-phobic old white man.
This is why researchers are now beginning to think beyond the traditional notion of the habitable zone. Indeed, some are already arguing that we are thinking too anthropocentrically and geocentrically if we focus only on Earth-like worlds and the conditions that are similar to our own planet. On the one hand, extraterrestrial life might need completely different conditions than we do. On the other hand, there could also be other types of planet that could offer even better conditions for life than Earth itself by earthly standards. And such planets that are better than Earth are called superhabitable exoplanets. I know it sounds kind of illogical. It's like there's something that tastes more like pizza than pizza. Super pizza. With super calories. But that actually makes sense, because we are talking about planets that may have an even greater chance of harboring life than Earth, and on an even greater scale. In other words, conditions that enable even greater biodiversity and higher biomass. Like Earth, only more of everything. But how do you look for it? There are various factors that can make a planet viable from our point of view. Size and mass play a role, as a larger planet can have a larger habitable surface and could maintain a more stable atmosphere. The age of a planet is also important, as older planets have more time to produce complex life forms and accumulate a greater diversity of life. In addition, other factors such as the type of star around which the planet orbits and the composition of the atmosphere could also play a role. So you see, there are a variety of ways in which a planet could be superhabitable. And without researching specific planets, it's very difficult to gain tangible insights into this. I can already hear some of you shouting indignantly.
But the title says something about concrete planets. That's clickbait.
Take it easy, people. Such planets do exist. Astronomers have already found 24 candidates, and the most likely contender bears the easy-to-remember name KOI 5715.01. Another astronomer has fallen asleep on his keyboard. This planet really has what it takes to be a superhabitable exo-Earth. It is located in a star system that is around 2,965 light-years away from us and has an orange dwarf star at its center. The planet, which I will now call KOI for the sake of simplicity, is about 5.5 billion years old and has a diameter of 1.8 to 2.4 times that of the Earth. Here you can see what this planet might look like. Unfortunately, there are no real images of its surface at such a distance. But why is KOI in particular now considered a hot candidate for a better Earth? Firstly, because of the age of the star system. At 5.5 billion years old, it is almost a billion years older than our solar system. It is estimated that it took 3.5 billion years for complex life to emerge on Earth. And an older star system has simply had more time to develop complex life. In addition, KOI orbits the perfect star, while yellow dwarf stars, like our Sun, are often seen as promising candidates because we know no other way. Researchers have also focused on orange dwarf stars because these stars are cooler, dimmer, and less massive than yellow dwarfs. They could therefore offer optimal conditions for life, as they have a longer lifespan, and this gives the planet in their habitable zone more time to develop life and accumulate more biodiversity. Another aspect is the size of KOI, which is larger than that of our Earth. In the search for superhabitable worlds, scientists are on the lookout for precisely such planets that are slightly larger and slightly more massive than Earth. Why? Remember the Great Pizza.
The bigger and bulkier the pizza, the happier the person. Confucius already said that.
This difference in size and mass would help the planet to store heat. And if it could store more greenhouse gases in its more massive atmosphere, this would probably lead to much higher biodiversity. There are indications that the average temperature of KOI could even be slightly lower than that of the Earth. But that doesn't mean anything. It may still have more greenhouse gases overall despite the lower average temperatures. But of course, higher average temperatures would be better for more life. Nevertheless, KOI has directly fulfilled three important factors for a superhabitable planet. Older than our solar system, an older orange dwarf star and slightly larger in size and mass than Earth, potentially allowing for more greenhouse gases and biodiversity. In order to gain more definitive knowledge about this exciting planet, we should urgently take a look at it with the James Webb Telescope. That hasn't happened yet, but I'm sure that KOI 5715.01 is at the top of the list, and as soon as we have more information, I will of course keep you up to date. But there are probably also candidates for superhabitable exoplanets in our immediate galactic neighborhood, such as Speculus 2c, which is only 106 light-years away. In any case, it is clear that with at least several hundred billion planets in our Milky Way galaxy, superhabitable worlds definitely exist, and we probably already know of some. We just need to investigate them more closely. Let me know in the comments if you would move to a superhabitable world like KOI if you had the chance. A new life on a better Earth? Well, the higher gravity could be a bit exhausting in the long run. But anyway, write me what you would do. I'm very interested in whether you would move to a new planet. The most exciting question about exoplanets is of course always, is there life there? And for a long time it was thought that many planets were out of the question, as they always face the same side of their star and therefore have extreme temperatures. But as we have now discovered, these very planets could be alien-friendly. Fasten your seatbelts, it's off to the Terminator zone. Earth really is my favorite planet. It has pizza, YouTube, and you don't die of apocalyptic temperatures. One of the reasons for this is that the Earth has no bound rotation in its orbit around the Sun. Bound rotation means that a celestial body rotates around another celestial body in such a way that it always shows the same side to it. This is the case with our Moon, for example. Due to the tidal forces in the Earth-Moon system, the Moon's rotation has stabilized in such a way that it always shows us the same side. Here at the planetarium we have a beautiful model that shows this very clearly. And many people mistakenly believe that the Moon does not revolve around itself at all. But the opposite is true. If the Moon really didn't rotate around itself, we would always see a different side of it. And it is precisely this bound rotation that is probably the undoing of many alien species in the galaxy. A not inconsiderable proportion of the exoplanets in our galaxy are very close to their star. And they have a bound rotation, which means that one side of the planet always faces the star and the other always faces away. So perfect for a very trip on your next summer vacation. On one side eternal sunshine, a pleasant 500 degrees Celsius, on the other side an eternal night with a beautiful starry sky and a refreshing -200 degrees Celsius. Would be a good location for the next season of the Jungle Camp. Here is just one extreme example of such a planet. Kepler 10b orbits its star at a distance 20 times less than that of Mercury around the Sun. Accordingly, it is incredibly fast and only needs one Earth day to orbit its star. Due to the extreme temperatures caused by the bound rotation, it rains molten iron. And the fierce, high-energy stellar wind hurls this iron rain away from the planet. So that Kepler 10b drags a fiery tail of molten iron behind it as it jets around its star. Doesn't sound very pleasant, and for a long time, astronomers assumed that life was impossible on such planets. How could organic structures form under these extreme conditions? Both the immense heat on the day side and the freezing cold on the night side seem to be relatively hostile to life by our standards. But what about the zone that lies exactly between the two gravitationally bound sides? Shouldn't there be a certain area there where the temperatures are pleasant? Yes! And researchers call this the terminator zone. Such rotation-bound exoplanets are also known as eyeball planets due to their appearance, and a team of scientists has now run climatic simulations for exactly this type of exoplanet. Here you can see what such a planet might look like: liquid water and comfortable temperatures right between the two extreme zones. And only there could life develop as we understand it on Earth. Incidentally, the name for this zone, Terminator, does not come from Arnold Schwarzenegger, but from the astronomical term terminator, which refers to the day-night boundary of a planet. In contrast to Earth, for example, this day-night boundary is fixed on the eyeball planets and always remains in exactly the same place. Imagine an alien civilization on just such a planet, surrounded by a gigantic sand desert and an equally gigantic ice desert, with all the flora and fauna taking place in this thin strip. Incredibly fascinating thought, and as the researchers found out through their simulation, it would actually be bad for such planets if there was too much water on the surface. If the day side had liquid oceans, the interaction with the star would fill the atmosphere with vapor that could envelop the entire exoplanet, leading to suffocating greenhouse effects. Then the eyeball planet would become a sauna planet, whereupon a finished space mission would presumably set off immediately. However, if the exoplanet has a lot of land and few oceans, then the Terminator becomes more habitable. The water would then have to come not from vapor in the atmosphere, but from the glaciers on the night side, which protrude into the Terminator belt and begin to melt there. In this way, melted ice would create a life-friendly ring around the planet in the Terminator zone. The astronomer involved, Ana Lobo, says, "We are trying to pay more attention to planets with limited water resources. Although they don't have large oceans, they could have lakes or other small bodies of water." So what does this tell us about the search for extraterrestrial life? We should look for rotationally bound exoplanets, especially in star systems with a red dwarf star at their center. This is because it is particularly common for planets to be closer to such stars and develop a bound rotation. Conveniently, such star systems make up 70% of all stars visible in the night sky. And that shows how revolutionary this new research work is. Previously, most astronomers assumed that we could disregard 70% of star systems in the search for aliens, because life doesn't form on rotationally bound red dwarf eyeball planets anyway. Now these star systems are potential opportunities to find life again because we understand the Terminator zones better. Wow! Eyeball planets. Rotationally bound aliens. Terminator zones. Let someone else say that science isn't exciting. Rotationally bound planets, second Earths, super habitable worlds. When it comes to exoplanets, there really is everything you can imagine. But there's one type of exoplanet that really goes beyond imagination. Planets that fly all over the galaxy and could serve as planetary spaceships for aliens. Get ready for rogue planets. Although I'm always very optimistic about the future, I have to admit that traveling to the stars will be at least somewhat difficult. Because the distances in our galaxy alone are so gigantic that even with the most advanced methods of travel, we won't be able to cover them. Assuming we could one day build spaceships that could fly at the speed of light, and that is, after all, the fastest that exists according to the laws of nature, then we would still need just over 4 years at the speed of light to reach our neighboring star Proxima Centauri alone. So unless something really unforeseen happens and Z from Cochrane in Star Trek invents the warp drive, alien star systems will probably always remain close to us. And all other intelligent alien species in our galaxy should theoretically face exactly the same problem, because the laws of nature apply equally to all of them. So every alien civilization would eventually reach the point where it could not develop propulsion systems fast enough to leave its own star system. So is the Milky Way full of millions of alien species, all squatting on their planet, wanting to meet up but prevented by the laws of nature from fulfilling their cosmic destiny? Very possible, unless some aliens have taken very unusual measures and developed a very long-term tactic to reach and colonize several stars after all. I'm talking about so-called rogue planets. Most planets in our galaxy have their fixed place and orbit around one or more stars. But there are also outsiders who have no interest in this galactic rut and refuse to orbit stars in a fixed path. These planets fly all over the galaxy. Some have even been ejected from the Milky Way and are now traversing the cold, empty, black intergalactic space. In a nutshell, You could say that rogue planets are planets that do not belong to any system and move vagabondly through space. So far so good, but I can already hear some of you saying that.
Why is that weird man on the internet telling me about rogue planets? I want to hear about aliens.
Rogue planets could be a way for aliens to leave their own star system. In a research paper, astronomy professor Irina Romanovskaya writes the following. I propose that alien civilizations could use free-floating planets as interstellar transport to reach, explore, and colonize planetary systems. She calls it the cosmic hitchhiker hypothesis, and that describes quite well why it could be attractive for aliens or even for us to use such rogue planets as spaceships. Because if they were to fly by nearby anyway, you could simply take the opportunity to hitch a ride like a hitchhiker, and then hope that it doesn't turn out like the carpooling in the horror movie. Rogue planets could therefore represent a kind of natural spaceship, a kind of galactic ride. Of course, rogue planets would also need ages to arrive in a foreign star system. In other words, the whole principle would function more like a generation ship. Some representatives of an alien species would settle on the rogue planet, and their descendants, the alien great-great-grandchildren, would then possibly arrive in another star system where there are new worlds to colonize. Of course, this raises a lot of questions. Why would you take a planet and not build a generation ship directly? And how would you survive on such a rogue planet if it is drifting far away from any star? Rogue planets could in fact simply have the perfect natural conditions for a cosmic journey. Astronomers believe it is possible that many rogue planets have subsurface oceans. The energy that keeps the oceans liquid comes from the planet's interior and from the time before the planet became a vagabond and orbited a star. Even in deep space, these subterranean oceans would still be supplied with enough energy from the planet's interior to remain liquid and harbor life. A base on a rogue planet would therefore have to be built below the surface. We're talking about aliens traveling through the Milky Way on their way to new colonies on planets where they have built cities below the surface and feed on an underground ocean. Let someone else say that astronomy is not exciting, and it becomes even more conclusive, because water is also perfectly suited as a protective shield for the dangerous cosmic radiation, which naturally becomes much stronger in the interstellar region. Such a rogue planet would therefore be the perfect natural spaceship, much better than anything that could be produced artificially. If an alien civilization understood this, then it would be an absolute waste to leave a passing rogue planet unused. The question now, of course, is whether we could track down such an alien rogue planet. It would be interesting to know whether the Milky Way is full of extraterrestrial echoes. Professor Irina Romanovskaya writes, I propose possible technosignatures and artifacts that can be generated by alien civilizations that use free-floating planets for interstellar migration and interstellar colonization, as well as strategies for finding their technosignatures and artifacts. So when we observe rogue planets, we should pay attention to small details, such as unusual infrared radiation, which could be seen very well with the James Webb Telescope, for example. These could be signs that the alien passengers are giving themselves away. I know it all sounds a bit crazy, but it's too conclusive not to be a reality somewhere in the universe, because consider the following. According to the latest estimates, there could be 50 billion rogue planets in our Milky Way alone. 50 billion! There must be passengers on one of them, right? It is also conceivable that extraterrestrial species did not colonize a rogue planet on purpose, but that perhaps their own planet was thrown out of their star system by collision. Imagine the Earth were to leave the solar system for whatever reason. Then most of the living beings on this beautiful planet would surely die, but a very few would perhaps manage to continue to exist underground with the help of water deposits and the warmth of the Earth's core. Then the Earth would also be a rogue planet. But there are also other candidates in our solar system that we could perhaps use as galactic hitchhikers. Sedna, for example, a trans-Neptunian object that is very probably a dwarf planet but has not yet been classified as such, has an extremely elliptical orbit around the Sun. It would therefore not be so difficult to influence the orbit slightly so that Sedna would be catapulted out of the solar system. Such celestial bodies could be well suited to being deliberately converted into rogue objects. Of course, a small celestial body like Sedna would offer absolutely poor conditions and would only be able to support very few people, if any. It would therefore only be a kind of last resort, a cosmic lifeboat, in case, for example, the Sun dies in the distant future and we humans have not yet thought of another way out. We would then have to look for ways to bring at least a few members of our species to safety in order to ensure the continued existence of Homo sapiens. I will of course live stream the cosmic journey on Sedna for you on YouTube when the time comes in a few billion years. I would be very interested to hear your opinion. What do you think of the idea of rogue planets as spaceships for aliens? Are there really aliens out there flying through the Milky Way on rogue planets, or is that absolute nonsense? Be sure to write your opinion here in the comments. Maybe we can get an exciting discussion going, and I'll try to answer as much as possible. Almost all of these planets that have been found so far are located in the Milky Way, even in our direct galactic neighborhood. And even in this small area, there is already such a gigantic variety of extraterrestrial worlds. But some time ago, astronomers made a galactic breakthrough in the truest sense of the word. They found the first exoplanet outside the Milky Way in another galaxy. So now we are traveling millions of light years and taking a look at the first extragalactic planet. Exoplanets are the stuff of astronomers' dreams, because it seems that the entire cosmos is full of these alien celestial bodies, and who knows what we might discover on them. Strange elements, unexpected extreme conditions, or even life. Our own Milky Way seems to be full of them. But first things first, what is an exoplanet anyway? In principle, it simply means a planet in another star system. The first exoplanet was only discovered in the 1990s, and since then we have refined our methods. The best and most popular method for discovering exoplanets in the Milky Way is the so-called transit method. This means that you look at a foreign star. Stars are much bigger than planets in the vast majority of cases, which means you can get them into the telescope relatively easily and then observe their brightness. If this brightness decreases for a short time at some point, then there is much to suggest that an exoplanet has passed in front of the star. So to clarify, if aliens were observing the sun, they would notice a dimming every time Jupiter, for example, passed in front of the sun. A transit that triggers the dimming, and this is how the vast majority of exoplanets in the Milky Way have been discovered so far. Now it is not so far-fetched to assume that there must also be lots of exoplanets in other galaxies, because as far as we know, most galaxies look similar to our Milky Way, i.e. a gigantic collection of billions of stars with planets and a supermassive black hole at the center of each galaxy. Galaxies can have different shapes, but the basic pattern is always the same, and the vast majority of galaxies are probably spiral galaxies, like our Milky Way. The only problem is that it is super difficult or even impossible to look into other galaxies. This seems surprising at first, because there are fantastic images of other galaxies, for example this one of our neighboring galaxy Andromeda. Totally impressive. But even with the best telescope on Earth, it would not be possible to zoom in closer and resolve individual planets. The reason why we can see strange galaxies at all, even though they are so incredibly far away and we can only see them from our position on the edge of the Milky Way, is that they are simply incredibly large. It's almost impossible to look past them. I live in Cologne in Germany, so let's assume you're standing somewhere on the other side of the Rhine and you can see Cologne Cathedral in all its glory on the horizon, because it's just really big. But it's impossible to resolve details. For example, you wouldn't be able to see if anyone was standing in the cathedral and waving at you from the window. It wouldn't be possible. You can see the object itself, but no details. It's the same with strange galaxies, and these are the reasons why scientists have never yet seen an exoplanet in an alien galaxy, even though there must be plenty. The Andromeda galaxy alone has up to 1 trillion stars, and if we also apply the two-planet formula, we get up to 2 trillion planets. There's no shortage of exoplanets in foreign galaxies, but they are simply too small and too far away, which is why it hasn't worked out so far. Until now, because now scientists have achieved a sensational breakthrough, namely they have very probably discovered the first planet in a foreign galaxy, namely in the so-called whirlpool galaxy. Very creative name, because it looks like a whirlpool and it is 25 million light years away from us. That's quite a long way away. Even at the speed of light you would still be 25 million years away. The Whirlpool Galaxy is something very special, because it has a small companion galaxy called NGC 5195, and this companion galaxy that surrounds it is currently merging with the Whirlpool Galaxy. You can see this really well in the photos. And as a result of the fusion, a lot of new material, i.e. gases such as hydrogen, gets into the Whirlpool Galaxy. So it's a kind of influx of gases, and as a result there is massive star formation in the Whirlpool Galaxy. Normally, in older galaxies like the Milky Way or the Whirlpool Galaxy, there is actually no major star formation, because that only happens in young galaxies. At some point, all the gas is dispersed, but the Whirlpool Galaxy is super active due to the collapse of the companion galaxy. Lots of new stars are being formed, and that's why this galaxy has already been very well studied, because you can study a lot of star formation processes there firsthand, and that's why there are incredibly fascinating images of this galaxy. I have picked out a few for you from different spectral ranges and put them together. Take a look at them. It really is a beautiful galaxy, and the first non-galactic exoplanet has just been discovered, and it has the fantastic name M51 ULS-1b, which sounds very bureaucratic. Maybe they will come up with a better idea. If you have an idea for a name for the exoplanet, please let me know in the comments. And this planet is a so-called exosaturn, which means it's a gas planet with rings, so it's similar to Saturn but in a different star system. So how did scientists manage to track down this exosaturn in the Whirlpool galaxy? By using a new method, the so-called X-ray transit. I've already told you about the normal transit method, in which you simply measure the decrease in brightness when a planet passes in front of a star. With the X-ray transit, you observe the effect of X-rays when a planet is in front of its star. X-rays are a specific form of electromagnetic wave, and the X-rays from a star can interact with the gaseous atmosphere of a planet. The denser the atmosphere of a planet is, i.e. in the case of gaseous planets we only have a layer of gas, the more intense the interaction with the high-energy X-rays. This X-ray transit method was used to detect an exoJupiter in the Milky Way for the first time a few years ago, and the results were truly astonishing. Namely that it loses 100 million to 600 million kilograms of mass per second due to the interaction with X-rays. This means that the high-energy radiation hits the lane of the planet and the gas shell evaporates at a rate of millions of kilos per second, which is unimaginable. And such a massive vaporization effect can be perceived in the X-ray range. In the case of our exoplanet in the Whirlpool galaxy M51 ULS-1b, the evaporation effect caused by the X-ray radiation from its star appears to be so massive that we can even see it at a distance of 25 million light-years. The planet is being destroyed by its star more and more every second. This discovery is considered very certain, but in science it is usually done in such a way that you look a second time to confirm the discovery. Now the problem with this transit method and also with the X-ray transit method is that decades can pass before the planet is next seen from Earth in front of its star. It first has to make another complete orbit around its star. Saturn, for example, in our solar system, takes 29 Earth years to complete one orbit around the Sun. If our exosaturn also takes this long, then we won't be able to look at it again for another 29 years. Perform another X-ray transit and then perhaps confirm the whole thing. But it is considered very certain, only the confirmation will take a few more decades. What we have found out so far about exoplanets is incredible and goes beyond imagination. And this is just the beginning. The coming years will bring us thousands, if not millions, of new planets in the astronomical catalogs. And surely, at some point, extraterrestrial life will even be found on one of them. I will of course keep you up to date on this, but you can only do that if you subscribe to my channel. I know from the YouTube statistics that the majority of viewers have not subscribed to the channel. It's completely free, which helps me a lot and you won't miss any more galactic videos. So everyone, press the subscribe button. Now let's travel from all the foreign exoplanets back to our own Earth, because it too could change its appearance dramatically in the future, and the polar vortex is to blame. Find out what this icy force will do to the planet and why we can expect a massive ice age in the video below. Be sure to take a look. And if you'd like to support my work, go to my space store and buy galactic things like the plush black hole that can be turned into a white hole. Every purchase helps me a lot to continue the channel. Otherwise, I'd say see you in the next video. Take care, guys.